In the previous movie, we created a gravity flow graph to control servo's fall speed. In this movie, we'll build on our work by making servo jump. Open the level Servo Jumping in your current project. You can also copy the content and script folders from the files provided with this movie into a new Stingray project. Open the Move Character Flow from the Asset Browser. In this flow graph, the vertical speed variable controls servo's mover position on the z-axis based on its own collision detection. We can use that same variable to set a jump offset. Duplicate the following setNumericVariable node and assign it a positive value. Now, create a GameController button node and connect it to the setNumericVariable node. Once servo's in the air, the collision detection will trigger the gravity flow graph, which will decrease the vertical speed variable and bring servo back down. Save your changes and test your level. Pressing the jump button doesn't seem to affect servo's vertical speed. That's because the following setNumericVariable node is keeping servo grounded to the level surface. We need to update our flow graph, so Stingray prioritizes the jump trigger over the gravity flow group. First, create two setBool variable nodes and set both their names to isJumpPressed. Set one node to true and connect it to the GameController button node's pressed port. Set the other node to false and connect it to the released port. Delete the existing connection to the following setNumericVariable node since we won't need it anymore. Next, create another setBool variable node and name it isGrounded. Connect it to the getMoverCollisions node, replacing its connections to the branch node. Now create a pair of getBool variable nodes to match your Boolean variables. Connect them together to a branch node using an AND node. Complete the flow graph so that a true output triggers the jump offset while a false output triggers the original collision detection branch node. Group your new condition flow graph as check for jump press while grounded. Connect this group to the sequencer node's out3 port so Stingray evaluates it after setting the Boolean variables. Offset all the other connections accordingly. Save your changes and test your level. Stingray now evaluates the jump flow graph first and the gravity flow graph second. Let's now optimize our flow graph by exposing some of the flow nodes we created so far as external input nodes so we can edit them in the unit flow. Start with the jump offset. Duplicate the following external input numeric node and rename it JumpSpeedIn. Connect it to a setNumericVariable node and name it accordingly. Use a getNumericVariable node to transfer jump speed to vertical speed. Repeat this process to expose the gravity strength and the maximum fall speed values. As we've seen in the previous movie, the Input Controls node in the unit flow aggregates all the input control data. Instead of leaving our jump trigger flow graph in the Move Character flow, we can transfer it to that one. Create an external input Boolean node and connect it to a setBool variable node. Rename the node accordingly. Select the Game Controller button node and its two connected nodes. Cut them and then save your changes. Open the Input Controls flow from the Asset Browser. Paste the nodes there. Duplicate the external InEvent node twice and rename them Input Jump Press In and Input Jump Release In respectively. Connect them to the setBool variable nodes based on their existing connection. Duplicate the following nodes and rename them to IsJumpPressed and IsJumpedPressedOut respectively. Finally, cut the Game Controller button node. Save your changes and open Servo's unit flow. Your flow nodes are updated with the newly exposed ports. Note that if your unit editor was already opened, the flow nodes may not update automatically. You'll need to close and reopen the unit editor to force a refresh. All that remains is to create the remaining variable nodes to connect to your flow node's exposed ports and to set the desired values for the gravity, jump speed, and max fall speed ports. Don't forget to paste your Game Controller button node and connect its pressed and released ports to the Input Controls node. When you're done, save your unit flow and test your level. In the next movie, we'll finalize our platforming flow graphs by triggering the corresponding animation clips.